Well, now we get to the sharp end of mathematics. This is level 3 calculus. Apply differentiation methods in solving problems. So differentiation. Every one of these questions, you're going to need to differentiate something. It's worth 6 credits and it is the fundamental calculus that you need to know. This is level 3 calculus, so I'm going to presume that you know your way around algebra, that you know what the chain rule, what the product rule, what the quotient rule is. To paraphrase Ice-T, the actor and rapper, this is not a pop album. This is level 3 calculus. So I'm going to try to stick to the formula sheet that is given to students this year. This is this year's exam sheet, and I'm also going to be using the most common calculator that's used by New Zealand high school students. I'm going to be taking a bit of a detour from the way that I normally answer these questions, and that I have actually had a quick look through these questions previously for the previous questions on probability and statistics. I've just gone in and answered them. I see them as you see them. Calculus is a bit different. It does often entail kind of going off on tangents and then abandoning those tangents. And that would just be a really, really boring, counterproductive video. So I had a quick look through some of the tougher questions just to make sure I understand them properly and how we're going to be answering them. So with that said, let's do it to it. Whenever you answer any calculus question, especially at this level, you should be thinking, which rule am I going to use? So the first one asks you is to differentiate this thing here, and it's a function within a function. So we're going to use the chain rule. So I'm going to say let u be equal to 5x cubed minus 2x plus 1. So f of x is going to be equal to u to the power of 5. So therefore f dash of x, prime of x, is going to be, we're going to differentiate we're going to differentiate f of x with respect to u times, we're going to differentiate u with respect to x, and you're going to cancel it, and we're going to be left with the f dash of x. Okay, what do we do first? So let's differentiate this one first. So f dash of u is just going to be 5u to the power of 4. We just use the power of. When we differentiate u with respect to x, and I know that I'm mixing up the notations here a bit. I prefer Newtonian notation. I just do. When we differentiate this thing here, we're going to get 15x squared minus 2. So when we multiply them together, we can get 5u to the power of 4 times 15x squared minus 2. We didn't have a u in the original question. It's just a dummy variable that we came up with, but fortunately we know what u is. So u is going to be 5 times 5x cubed minus 2x plus 1 multiplied by 15x squared minus 2. And it's going to be to the power of 4 here. Now, don't fall for the trap of trying to open up these brackets or multiply through. You can't do it because it's to the power of 4. You can just leave it like that. It just says you do not need to simplify your answer. So that's going to be our final answer. So the next question is a fairly standard calculus question. C is given as the temperature of an oven, 60 over square root of T plus 5 square root T plus 15. Where C is the temperature in the oven in degrees Celsius and T is the time in minutes after the oven has been switched off. So in minutes after the oven has been switched off, so that's interesting. So when we differentiate, it's going to be degrees Celsius over minutes. So find the rate of change of temperature in the oven 4 minutes after the oven was switched off. So it's probably going to be a negative answer. Just sort of heads up. So what I'm going to do, I'm going to just rewrite this. So C is going to be equal to 60 T to the power of negative 0.5, which is the same as the square root. It's really nice now because we can use the power rule. Plus 5T, whoops, should be negative 0.5. 5T to the power of 0.5 plus 15. So this now makes it C as a function of T. So C prime of T is going to be negative 30 T negative 1.5, yeah, 0.5 minus 1 is negative 1.5 plus 2.5 T to the power of negative 0.5 and 15 goes away. Now we're asked to say, is this going to be positive or negative after 4 minutes? It's probably going to be negative. We hope it's going to be negative because we don't get heat from anywhere. So we want C prime of 4. So it's going to be negative 30, 4 to the power of negative 1.5 plus 2.5 times 4 to the power of negative 0.5. And this is now a problem for Mr. Casio. While we're here, I'm just going to set it up so that we're in radian mode. Make sure that it's in radian mode. Everything in this level has to be in radians unless they tell you otherwise. So minus 30, 4 to the power of negative 1.5. I'm going to do it in watts, so negative 3.75. And let's do the other bit. 2.5 4 to the power of negative 0.5 is 1.25. Yeah, that would make sense. 1.25 plus 1.25, and that's going to be some number. It's going to be minus 2.5, isn't it? Yes, minus 2.5. What's the unit? Minus 2.5 degrees Celsius per minute. Don't have it as T there, you've got to have the unit. They give it to you here. I guess you could say change in degrees Celsius, but it doesn't really matter. Make sure it's negative. That shows that it's decreasing. If you had a positive, you'd kind of be right because that would be the change, but it's declining. You really, if you had that information, you really should state that. So it is decreasing in temperature, which should really be much of a shock horror thing. When you take things out of the oven, they tend to cool down. That's why you take them out of the oven. This is a question that gets students in a lot of trouble. They try to sort of overthink the question. It looks a little bit intimidating. We want to find the normal to the curve. So if you don't know what a normal is, you're going to be stuck from the beginning of this curve here. Y equals sine cube x cos x when x equals pi over 4. Remember that sine cubed of x is not sine of x cubed. It is not that. Sine cubed of x is sine of x all cubed. So here we have a chain function and a product function that we're going to need to use. So we need to differentiate that and then differentiate x cos x and then put the pi over 4 into the end. And there is something here, pi over 4, if I remember rightly, about that. Okay, so what do we do? Well, let's let sine of x be equal to w, and let u be equal to sine cubed of x, and v be equal to cosine of x. We want to differentiate u with respect to x, but to do that we need to differentiate u with respect to w times w with respect to x, and the w's and dw's will cancel out. So du with respect to dw is going to be 3w squared times, and now we need to know what the derivative of x sine x is. Hopefully you know that. Hopefully you do know that. It's in the tables. So sine x, when we differentiate it, it becomes cos x. Cos of x. But we didn't have w when we started. W was sine of x. So 3 sine squared of x cos of x. And that's du. So that's u done. That's, call that u dash. Now we've got v. We need v prime. I keep saying dash. U prime. And when we differentiate cosine of x, we get negative sine of x. So now we have enough to differentiate this. So we're going to use the product rule. So d dy dx is going to be equal to u dv dx plus v du dx. So u is given as sine cubed of x, and dv is minus sine of x, plus v is cosine of x times u dash 3 sine squared of x cosine of x. I think that's right. I'm just going to check. Yep, I just checked that is right. So this is going to be equal to minus sine 4 of x plus, now let's bring this 3 out, cosine squared of x. When that one's done, let's bring out the front. Sine squared of x. Yes, that makes sense. The sine squared is done, the cosines are done, the 3 is done, and it's a plus. Okay, now we have enough to keep going. There's a trick here. Let's work out what sine of pi over 4 is, and let's work out what cosine of pi over 4 is going to be. And if I'm not mistaken, I think it's square root 2 over 2, but let's make sure. So sine of pi over 4 is, I know that it's square root 2 over 2. It's one of those ones, and back in the old days you had to memorize them, but it's going to be square root 2 over 2. And I remember it because cosine of pi over 4 is also square root of 2 over 2. So now we're pretty hanging tough. So it's going to be negative square root of 2 over 2 to the power of 4 plus 3 times square root of 2 over 2 squared times square root of 2 over 2 squared. Okay, what's that going to be? Let's do this one first. So negative, I'll put it in the formula that I like. Should use lots and lots of brackets. So power of 4, negative 0.25 plus, yeah, square root of those brackets, square that, 0.5, and we're going to double it because there's 2 of them. Then we're going to multiply that by 3. So that's going to give us 3. And we take 0.25 off. 2.75. Thought that I'd made a mistake. We're not going to double it, we're going to multiply them together. So square root of 2 over 2 squared is going to be half times a half. Just because there's 2 of them doesn't mean we add them because there's no addition sign there. So we're going to multiply them. So 3 times a quarter is 3/4. So 3/4 minus a quarter is going to be 0.5, which is 1 over 2. And so that's our gradient is 1 over 2, which means that the gradient of the normal is going to be negative 2 over 1. Remember, we flip them and make it a negative sign. Yeah, they tripped me up. I thought that's not right. What have I done wrong there? That's what I did. I added them instead of multiplied them. Sorry about that. This one looks really nasty. It's actually not really nasty. So we're given a sort of curve here, and it has this form here. Y equals x squared plus e to the 2x. we're told that a tangent here in x equals 1 exists, but we're not told what the gradient of that tangent is, and we're not even asked the formula for that. We're asked the point P where it crosses the x-axis. Okay, let's just divide and conquer. So if this is y here, dy dx, we're going to differentiate the first bit, 2x plus, and we're going to use the nice little thing that I've given us there. So it's going to be 2e to the 2x. That's going to be the gradient for all points on the curve. What we need to do is we need to know what the y value is, and we need to know what the gradient is when x equals 1. So dy dx evaluated when x equals 1 is going to be 2 times 1, which is 2, plus 2e squared. Right, so this point here is 1 comma 2 plus 2e squared. All right. Sorry. The gradient is going to be 2 plus 2 e squared. We don't know what the y value is yet, but it's going to be pretty easy to work out. We just put a 1 in here. So y evaluated when x equals 1 is going to be 1 squared, which is 1, plus e squared. So 1 plus e squared. So now we have a point, and we have the gradient of that point, and now we can find the equation of that line. We don't even need to do that, because remember when we're finding the root, the x-intercept, y equals 0. So let's do it, and we know that y minus 1 plus e squared is going to be equal to m, which is 2 plus 2e squared x minus 1. Let's run in here. So it's the same as the y minus 1 equals m x minus 1. Yeah, we know y minus y1, that one there. Maybe I'll do that a bit nicer. Y minus y1 equals m x minus x1. That one there. All right. We know that y equals 0. So 0 minus that is minus 1 plus e squared. So it's going to be minus 1 minus e squared. And that's going to be equal to this thing multiplied out. So 2x plus 2e squared x. Let's get rid of this again. So that one done, now I'll do one with the negative 1. Negative 2, negative 2e squared. All right, so we want to solve for e. We want to solve for x. Sorry. How are we going to go about doing that? Well, let's bring everything which has x over this side and everything which doesn't have an x over this side. So we've got negative 2x, negative 2e squared, x equals 2 plus 1, negative 2 plus 1 is negative 1, negative so negative 2e squared plus e squared is e squared. Yes, that makes sense. We can flip those around to make it make a bit more sense. Now what do we do here? We want to isolate x, so we're going to factorize this. We're going to factor out the x minus 2 minus 2e squared equals negative 1, negative x squared. X is therefore going to be equal to negative 1, negative e squared over this negative 2, negative 2e squared. And that's going to be a number. What it is, I'm not sure. Let's put it up. I can look at it now. I can pretty much guess what it's going to be, but let's just change. We could change the sign up. Leave it like that. So brackets negative 1, negative. It's E on these calculators. E squared divided by brackets negative 2, negative 2 e squared, close brackets. Hey presto, it's halved. All of that work adds our final answer. Isn't calculus great? Next, we're asked to deal with a parametric equation. So a parametric equation is when we have x and y usually in respect to some third variable, usually t. And we're asked this time to differentiate these two and find the points of inflection and the stationary points. So how do we do that? Here is the formulae that are given to you in the exam. So first thing we need to work out is what is the point of inflection, what's the stationary point. The stationary point is when dy dx equals 0. The point of inflection is when d squared dx squared, in other words, the second derivative equals 0. So we need to work out all of the stationary points, all of the points of inflection, and find which are in both of those groups. So let's do this one first. So if x is 3t squared plus 6t plus 1, then dx dt is going to be 6t plus 6. Does that help us find what dt over dx is? Yeah, it does, because dt over dx is 1 over that. Right. So now we're given y as 2t cubed. That means that dy dt is just going to be 6t squared. Let's multiply those out together. So dy dx is going to be 6t squared over 6t plus 6. And I can see a simplification straight away. 6t squared over 6t plus 1. So those are going to cancel, and we're left with t squared over t plus 1. All right. Now what do? Well, we set that equal to 0 and solve. Let's multiply both sides by the denominator, and we're left with t squared equals 0. 0 times all of this is 0. So there is only one solution, and that is t equals 0. All right, now let's take what to do. We want to differentiate this one here. So we want to differentiate with respect to t squared over t plus 1 times dt dx. Now, remember, dt dx is this. So we have to multiply this by 6t plus 6. We can't simplify that. We simplified it after we combined them, so we have to put it in that form. So first thing we have to do is we have to differentiate this. And to do that, I guess we're going to need to use the quotient rule, aren't we? Okay, let's use the quotient rule to solve this. So it's in the form u over b. So u over b prime is u dash v minus u v dash prime over b squared. So u is t squared, so therefore u prime is going to be 2t. V is t plus 1, and that means that v prime is just going to be 1. V squared is going to be t plus 1 squared, which is t squared plus 2t plus 1. Yes. Let's combine them. So 2t times t plus 1 minus u, which is t squared, 1, which is just t squared. It's good. Over t plus 1 squared. I'm just going to leave it like that for now. Let's just expand this out. So it's going to be t squared plus 2t minus t squared. Okay, so that's going to simplify a little bit. That's going to cancel. So we've got t squared plus 2t over t plus 1 squared, and we have to multiply this by this thing up here. So we end up with, at the end of it, the end of all of that, we end up with t squared plus 2t, 6t plus 6, t plus 1 squared, and we set that equal to 0. And that's really, really great because we multiply both sides by the denominator, and we're left with this. Aha. Let's factorize that, bring the t out. T plus 2 equals 0. So t must be equal to 0 or negative 2. And t equals 0 is the only one that was around before, so that's our final answer. So the only turning point is stationary point and a turning point at x equals 1. Did it want the actual coordinate? Yes, find the coordinate. At x equals 0. If x equals 0, t equals 0. Yes, t equals 0. at t equals 0, what am I doing? Let's go to the original equation. So 3t squared plus 6t plus 1. And we know that t equals 0. So 3 times 0 squared is 0, plus 6 times 0 is 0, plus 1, so it is 1 actually. So x equals 1, and y was 2t cubed, which is going to be 0 because 2 times 0 cubed is 0. So the point where the stationary point and the turning point is 1 comma 0. Into question 2. Now we're asked to differentiate this function here, 7 over x minus natural log of 3x cubed minus 2x squared plus 5. There is a shortcut here. I know that when we differentiate the natural log of some function of x with respect to x, the answer is always going to be but. Let's say we didn't know that. Let's do them. So let's do this first bit first. So I'm going to rewrite this as 7x negative 1. And when we differentiate that, it's going to be negative 7x negative 2. Very simple. So this one here, now we're going to subtract this. Now I'm going to let u be equal to this thing in the bracket here. Right, so now it is natural log of u. When we differentiate that, the answer to that is 1 over u, as per the formula. And then we have to multiply this by this differentiated, which is going to be 9x squared minus 4x, which is going to give us 9x squared minus 4x over this original u function. And our end answer is going to be this thing here, carried down, negative 2 minus 9x squared minus 4x. Guess we could factorize that if we wanted to. 3x cubed minus 2x squared plus 5. And that's going to be our final answer. So another word question. The depth of water in meters in the particular harbour, so here's our unit in meters, is given by the formula P equals 30t minus 5t squared, close brackets, e to the minus t, where t is time measured in hours between 0 and 4. Show whether the depth of water is increasing or decreasing after 2 hours. So in other words, we're going to set t equal to 2. All right. Let's differentiate this and let's use the product rule. So P is a function of time. You can rewrite it here. Okay, so I'm going to let that be U and that be B. So U is 30t minus 5t squared. Means U prime is going to be 30 minus 10t. V is going to be e to the negative t. V prime, therefore, is going to be negative. Yes, negative e to the negative t. And it's all we need to know. So therefore, p prime of t is going to be u that. So 30t minus 5t squared times minus t negative t plus, for us here, v e to the minus t times u prime 30 minus 10t. Right, now let's find the p prime of 2. I think we could probably simplify it a little bit, but let's not do that. Let's just go straight to the calculator. We can go straight to the answer. So let's do everything that's in brackets here. So 30 times 2 is 60 minus 5 times 2 squared. So 5 times 4 minus 20 is 40. Minus e to the power of negative 2. So 40 times e to the negative 2 times negative 1, because we have to put the negative sign in there. So that equals negative 5.413. And in here, so t so e to the negative 2 times 30 minus 20, it's 10 times 2 is 20, is that. So it's going to be plus 1.353, and that is clearly less than 0, so decreasing. I think of probably a couple of ways of doing it as well, but that's the most direct route that will probably give you the answer. It's kind of a brute force answer. We have a really, really interesting question. We're told that there are two tangents to this curve. So this is a separated curve, f of x, and here it is here, that have the equation y of x, y equals negative 3x plus c. The only thing you really need to know from this is that the gradient of this is negative 3. Right? So then it says find the coordinates of the 2 points of contact these tangents have the curve. So in other words, if you're sort of reading it, you want to differentiate this and find where the gradient is negative 3. X squared, x plus 4. So f of x is that. We want to differentiate this. So we've got a function over another function, so let's use the quotient rule. First thing we need to do is we need to work out what our u and v is. So u is obviously going to be the x squared, which means that u prime is 2x. The v is going to be x plus 4, which means that v prime is just going to be 1, and v squared is going to be x plus 4 squared, and it's going to be what, x squared plus 8x plus 16. Okay, we've got enough now to do it. So therefore f prime of x is always it's just a matter of putting these in. So 2x times b, which is x plus 4, minus u, which is x squared, times 1, that's good, over this beastie here. Let's expand this out a bit. So 2x squared, yeah, okay, we're going to cancel a little bit. Plus 8x minus x squared, so we're going to lose that. Lose that. Over this thing here. Don't think we can simplify this anymore, but we want to find where that equals -3. So I'm just going to copy that down a bit. Let's go about finding that. All right, well, let's multiply both sides by the denominator. It's always a good place to start. Okay. And let's open up this bracket. So that's going to be -3x squared, -24x, -18. Sixteen. Oh, lucky. 16. So 3 times 16 is 48. Yes, 48, I think. Oh, I need to look this up. 3 times 16 is 48, isn't it? Yes. Minus 48. Okay, so x squared plus 8x equals -3x squared, -24x, 48. Bring everything over to the left side, get it equal to 0, and then we can solve for x. So x squared plus 8x plus 3x squared plus 24x plus 48 equals 0, and it's combined terms, so 4x squared plus 8 plus 24 is 32x plus 48 equals 0. Okay. These, I think, is probably all divide by 4. They divide by 2 anyway, but I'm not going to worry too much. I'm just going to put it straight in the calculator. We've done all the calculus now. So polynomial solver, degree 2. 4, 32, 48, and we get -2 and -6. So those are our x coordinates, -2 and -6. Now we put them into the original equation here to find what the y number, so that is x squared, x plus 4. Okay, when we put in x equals -2 squared, -2 plus 4, so that's going to be 4 over 2, which is 2. So one of the points is -2, +2. Now let's evaluate that where x is -6. So -6 squared is 36 over -2, which is negative 18. And there's our answer. Those are the 2 points. Maybe circle them, highlight them, whatever you need to do, show that that's your final answer. Moving right along, find the equation of the tangent to the graph defined by the pair of equations. Pair of equations, they're parametric equations, aren't they? X equals 2 secant t and y equals 5 tan t at the point on the graph where t equals pi over 6. Now, your calculator will probably not have secant in it, so it really helps if you know this one. This one is from the formula. When we differentiate secant, we get secant x tan x. Just because we differentiate it doesn't mean that it becomes easier. Okay, what do we do first? First thing we need to do in order to find the equation of tangent, which is a straight line, we need one of the points. And we need the point where it crosses this line. So for this, the x coordinate is when t equals pi over 6. So 2 secant of pi over 6 is going to be the same as 2 over cosine of pi over 6. Now the answer to this one is not actually going to be shown on the calculator that I have here. Your calculator will show this number is 4 square root 3 over 3. Right, so the old emulator that I've got on my computer here is the only way you can get, and it gives it to you as a decimal fraction. I don't really want to know what it is for here. It's just nicer. Conversely, y is going to be equal to 5 tan of pi over 6. If you put this into your calculator, you should get 5 square root 3 over 3. And I just want to keep it there because that's going to make our life a lot easier at the end rather than having decimals. So now we've got the point that we want. It's going to be that comma that. Let's differentiate this. So dy dx is going to be equal to dy with respect to t times dt with respect of x. And remember, dt with respect to x is just 1 over dx dt. Right, so let's find dy dt first. So 5 tan of x. So y is 5 tan of x. When we differentiate it, we get secant squared of x. So dy dt is going to be 5 secant squared of x. And again, it's just going to be that squared. So 1 over cosine squared of x. And if x is, what is x? 2 secant of x, then dx dt must be 2 secant x tangent x. What's that? So dt dx must be equal to 1 over 2 secant x tan of x. Cool. Don't worry about these secants. I think they're probably going to cancel a little bit. Let's just press right ahead. So dt 5x that times this, so dy dx is going to be equal to 5 secant squared of x, remember it's 1 over, so it's the same thing here, over 2 secant of x tan of x, and that's going to be really, really great for us because it's 5, one of the secants is going to cancel, and secant is 1 over cos, 5 times 1 over cos of x, it's 5, 2, now remember tan is sine of t over cos of t. Okay, so when these cancel, these causes are going to cancel, and we're going to be left with 5 over 2 sine of t. We know what t is. T is pi over 6. So dy over dx is going to be 5, 2 sine pi over 6. I think pi over 6 is half, sine pi over 6 is half, isn't it? So sine, I remember correctly, yes, half. So it's going to be 5 over 2 times a half, which is 1. So 5 over 1 is 5. All right, so now we've got enough to find the gradient, the equation of this tangent. So we know that the gradient is 5, and it goes through the point. Just copying it up from the top. All right, so y minus y1 equals mx minus x1. That's just a third real number. That's a third real number. So y minus 5 square root 3 over 3 equals 5x minus 4 square root 3 over 3. Oh, we're nearly there. It might not look like we're nearly there, but we're nearly there. So y is going to be equal to 5x minus 20 square root 3 over 3, because we have 5 times 4 square root 3 is 20 square root 3, plus 5 square root 3 over 3. So this is going to be minus, so it's going to be 5x minus 15 square root 3 over 3. It's minus 15 because this is a minus here. Positive 5, negative 20. It's negative 15. Okay. They're going to cancel. They're going to go to 5. So our final answer is y equals 5x minus 5 square root 3. And that's the final answer. That was a really awesome question. This looks like a really, really daunting question. It's not an easy question, but it's not quite as difficult as it looks. What they're asking for here, it's the radius of curvature of a function is to measure how much a curve is bending at a given point. Really, really important in physics. Say grabbing my ballpoint pens can help me much. If you have something going around a corner, so your car's going around a corner, going in that direction there, how steep is this corner? Well, we imagine that this is part of a circle with that the center of the circle there, and that's going to be the radius of that circle. The smaller the circle, the tighter the turn. So if we can work out that radius, it's really, really important in physics and engineering. All right, but that's not going to help you right at this moment. So we're given this formula, P equals this monstrosity 1 plus dy over dx squared all to the power of 3 over 2 all over the second derivative of yx. Okay, this also looks kind of daunting, but there is a shortcut. Cos squared of x, remember, is cos of 2x times cos of 2x. And we have a little shortcut for that. We can turn it into a sum and not a product. So this is going to be equal to, we have to get rid of this 2, so there's going to be a half there. Cos a plus b, so 2x plus 2x is 4x. And put square brackets there, cos, and then cos of 2x minus 2x, which is 0. Now, cos of 0 is 1. So this simplifies much, much better to half cos of 4x plus half. And our life just got a lot easier. You could do it by chain rule, sine, cos, and all the rest of it. This will cut down a lot of work. You will eventually get the answer. In fact, I actually started doing that, and I kind of thought, there must be a simpler trigonometric identity that we can use. There must be cos times cos, surely. And I looked in, yeah, you're given one, so let's use it. So we're going to be using that one there. It really behooves you to know how to use those. All right, let's differentiate this then. So when we differentiate this thing here, so this is y, with respect to x, how are we going to do it? It's going to be a composite function. It's going to be a chain rule. So the inner rule is going to be 4x. So when we derive it, it's going to be half negative sign, yes, cosine, yeah, 4x is when we differentiate cos, it's negative sign, yes, times the derivative of the inner function, which is 4. This plus half goes away. So we're left with 4 times half, which is 2 times negative sign. The negative comes out the front. 4x. Yes, makes sense. And we're just going to park that there for now, because we're going to put in a number. We're going to put in this number here and find an answer. And we want to differentiate this again. So differentiate with respect to x again. And that negative 2 is going to come down. Sine, when we differentiate positive sine, we get cosine of 4x, and then we have to multiply by the inner function, which is 4. So we get negative 8 cosine of 4x. And that's that. So we're going to park this one now, because now we come to put in what we're actually wanting to find. So we need to find dy dx when x equals that, and d squared y dx squared when x equals that. So x over 3. So dy dx evaluated when x equals pi over 3 is going to be negative 2 times sine of 4 pi over 3. And I put that in the calculator and I get square root of 3. Again, these calculators, the calculator that I've got on screen here isn't that great. That's not going to give you a decimal answer. Now we want to evaluate the second derivative, where x equals pi over 3, and that's going to be about negative 8 cosine of 4 pi over 3. And the answer you should get should be 4. Now we can come up to our function at the beginning here and just put those numbers in and get an answer. So I'm just going to cut and paste that down now. So let's put in these numbers and see what we get. So dy dx is square root of 3, so 1 plus the square root of 3 squared is obviously going to be 3 to the power of 3 over 2 all over 4. So this is going to be 1 plus 3, which is 4, to the power of 3 over 2 over 4. And your calculator can definitely do this one. So 4 to the power of 3 over 2 is that. Divide that by 4, which should be the calculator, is 2. All of that just to get 2. So 2 is our final answer. It doesn't actually give us a unit, but that is our final answer. Not as tough as it looks. If you did sort of chain rule and product rule, and then into combined product chain rule, and you're gonna get there in the end. But knowing this rule here is going to make your life so much easier. The next question is pretty common of what you get every year in this exam. They give you a graph, and it's obviously a piecewise graph, and they ask you to tell them where it's not differentiable, etc. Now, the graph sort of goes here to a negative infinity, and then it sort of jumps here. The round empty circle means that it's not there, it's there. And then as soon as it gets any more than that, it jumps to here. And it goes there, and then it doesn't go there, it's suddenly there. It's kind of like Pac-Man or Doctor Who. And it goes up there, and then there's like a gap, and then there's like this parabola here. So where is it? What are the values of x where it's not differentiable? Well, it's not differentiable here. Because if we approach it from the right and the left, we get a different answer. So x equals negative 6 is one of the answers. The other place where it's not differentiable is here, because it's in two different places. So negative 2 is the other one. And then there is a gap here, and you can't differentiate something that doesn't exist. So 3 would be the answer there. Now it says, where is the gradient 0? So where is it flat? Well, it's flat everywhere here. So from -6 to negative infinity. And then it's flat here at -4. And then it's flat here at +6. Then it says a really interesting question. What is the value of the limit f of x as x goes to -2, which is here? And the answer to that is 2, because as we get closer and closer and closer, we're getting closer and closer to 2. And from this side, we get closer and closer to 2. The fact that it jumps up here is irrelevant. Where it is not really what we care about. It's where we're going as we get closer and closer. That's what the limit is. So yes, the limit as x goes to -2 is 2, and it does exist. Right? That's the answer to that. You should whiz through that question. So now we're asked to take the curve y equals natural log of x over 2x and find the coordinates of any stationary points on the curve. So in other words, we need to differentiate it and set it equal to 0. So if y is that, then dy dx is going to be quotient. It's one function over another, and that's going to be, oh, what is that? I always forget. It's u dash v minus uv. Yeah, that's the one. Over v squared. All right, so if u is natural log of x, u prime is going to be 1 over x. It should be the absolute value, but the formula sheet that you get doesn't have that. It says this one, and that's a u, a y, it looks like a y. And then v is 2x, so therefore v prime is going to be 2, and v squared is going to be 2x times 2x squared, so it's 4x squared. All right. Now let's combine them. So u dash v is 1 of x times 2x, that's great, minus the u natural log of x times 2 all over 4x squared. So let's simplify this a little bit, since it's going to be, this one here is going to be 2x over x. We're going to cancel, so it's just going to be 2 minus 2 natural log of x all over 4x squared, which is fantastic, because when we set that equal to 0, the bottom is just going to disappear. So 2 minus 2 natural log of x divided by 4x squared equals 0. That's going to go, because when we multiply, bring this across, multiply it by 0, it's still going to be 0. So what do we do now? Let's bring this 2 over. So 2 natural log of x is going to be equal to, minus 2, divide both sides by minus 2, so natural log of x is going to be 1. And we know if natural log of x is 1, x must be equal to e to the 1, or just e. And there's only one solution, so it's where x equals e. So then we come on to the top here and put an e into our equation and see what we get. So the natural log log of e over 2e. Natural log of e is 1 over 2e. So our point where there is a turning point is going to be e comma 1 over 2e. And that's our final answer. So let's highlight it. So we get to the rate of change problem. A solid spherical lump of ice is melting while maintaining its spherical shape. At the instant when the radius is 6, the radius of the ball is decreasing by 0.5 centimeters per second. So that means that change in the radius over time at that time is negative 0.05, and it's already in centimeters per second, which is good because this is a rate of change problem. Here's our original function. So find the rate of change at which the volume of the spherical ball is decreasing at the instant when the radius is 6 centimeters. And we're given the formula for the volume. So the volume is a function of the radius is 4 over 3 pi r square r cubed, and I'm going to just rewrite that as 4 pi over 3. I'm going to put that in brackets, r cubed. Pi is a real number, 4 is a real number, 3 is a real number, so this must be a real number as well. It's going to be an irrational number, but it's still a real number. So that tells us that dv with respect to time, which is what we're really looking for, is going to be equal to dv dr times dr dt, and the dr's are going to cancel. Well, we know dr over dt. It's that. So now we need to differentiate this. So we do that. 3 times 4 over 3 is 4 pi r squared. Okay, so the change of volume over change in time is going to be equal to 4 pi r squared times negative 0.05. Okay, yes. Let me check. Yes, I had to check that. It never hurts to check. So that's the rate of change, and we're going to evaluate that when r equals 6. So 4 pi times 36, because that's what 6 squared is, times negative 0.05. Now, what is that going to be as an actual number? Let's use our calculator. 4 times 36 is that, times 0.05, 22.619. It's going to be minus, and it's going to be centimeters cubed per second. And that's our answer. A reasonably easy question for a related rate of change. Okay. Well, we're really in the home straight now. Second to last question. Now we're given a parametric pair of parametric equations, x equals 5 over e to the power of 2t, and y is 5e to the 2t. Find the coordinates of the points where the gradient equals -2. Right. We need to differentiate both of these. In order to find the gradient, we need dy dx. And dy dx is defined as being dy dt times dt dx. Remember, where dt dx is equal to 1 over dx dt. Right, let's do them separately. So if x equals 5 over e to the 2t, I'm going to rewrite that as 5e to the minus 2t. And if I differentiate that, I'm going to be differentiating a function with e. So it's going to be dx dt is going to be minus 10 e to the minus 2t. It's in the tables, straight off the tables. What is dt dx? Well, it's going to be 1 over that. So dt dx is going to be 1 over minus 10 e to the minus 2t, and I guess you could kind of change that 2 to a positive, so it's going to be no. I'm gonna leave it like that for now and see how we go. Now if we have y equals 5e to the 2t. This is pretty easy to differentiate. We use that exponential power rules. It's the 2 here comes out the front. So it's going to be 10e to the positive 2t. So far, so good. Now we want to multiply those together. So dy dx is going to be equal to 10e 2e over minus 10e to the minus 2t. And that's definitely going to cancel. So the 10s are going to cancel. We're going to get with just e to the 2t over minus e to the 2t. That's going to be equal to minus e to the 4t. Which remember, minus e minus 2t is equal to minus e power positive 2t. So 4t. Okay. So now we've found dy dx. We need to find where this has the gradient of minus 2. So let's take this down here. Set it equal to minus 2. So take this. Yeah. Now what can we do? Well, let's get rid of this minus sign for a start. So e to the power of 4t is going to be equal to 2 multiply, in other words, multiply both by minus 1. All right, now what do? We need to get rid of this e, so we're going to need to take the natural log to get rid of that. So when we take the natural log of something, which is e, the bit that's out the front comes out the front. It goes from the superscript to the normal script. The natural log of e is 1. But if we take the natural log of one side, we have to take the natural log of the other side. So t is going to be equal to the natural log of 2 divided by 4, which is going to be a number, but I'm going to leave it like that for now. Now that we know what t is, we can put it into the original equations here to find the coordinates. So So 5 over e to the 2t. So x is 5 over e to the 2t. And we put t in, t equals this number in there. Do that using our calculator. I always use a calculator with these when I have e's and natural logs and different things floating around, because one little mistake can be pretty easy. So I'm just going to put that. So 5 divided by, it's going to be e, right, here we go. 2 times brackets natural log 2 natural log of 2 divided by 4. Now I have to make sure I've got the right number of brackets. 1, 2, 3, 4. 1, 2, 3, 4. 3.535533. I did this before on a Neo calculator, and the answer that I got for that was 5 over square root. But the answer that we got there is fine. When I put the 5 over 2 e to the 2t for the y number, I got 5 times the square root of 2. So our final answer is going to be 5 square root 2 comma 5 square root 2, but the decimal form would be 5. I'm just writing it like that. Again, the version of the calculator that you can get doesn't have that surd capability. It's a real pain in the neck. But I mean, 90% of your calculators will do that, and the decimal is fine. So on to the final question. The last question is a bit of a tricky one, and it is quite involved. So I've kind of had a look through. I haven't fully finished it yet, but I think I know how to solve it. We have a curve here, and this looks very much like a circle. Y squared equals 16x minus x squared. Well, we need it in the form, don't we? X plus, I'm going to use alpha. Sorry, it should be minus alpha squared plus y minus beta squared equals the radius squared. So how are we going to put it in there? You can see a way of doing it. So first thing we're going to do is we're going to bring over that x squared and the 16x and have it equal to 0. Right. Why did I do that? Well, we can put it in this form. It's it doesn't go up or down, so the center point here is going to be on the y-axis. Sorry, on the x-axis. So it's going to be y minus 0 squared, essentially. Right? Now, I'm going to just rewrite that here like this. I'm going to leave a gap. Let's see why. Because I'm going to complete. Is it minus? It's minus, isn't it? It's going to be minus, sorry. because I'm going to complete the square. Now remember how to complete the square? We half this, so we get -8, and then we square it. And then we add it and subtract it. So what I'm going to do is I'm going to add 64. I'm going to take 64 away. And then I'm going to factorize this bit here, and it's going to give me a perfect square. When we factorize this, it's going to give us x minus 8 squared. But we have to remember that this minus 64 is still there, and this y squared is still there, and it's still equals 0. So now we're almost at the stage where it's in this form that we like here. What we do, we will bring the 64 over. So it's going to be rewritten as x minus 8 squared plus y squared. I guess you could say y plus 0 squared, and it's going to be equal to 64. So in other words, this is going to be a circle with its center on the point 8, 0. And that's going to be important. So this point here is going to be 8, 0. Now what I'm going to do, I'm going to set up a set of rules to describe this width here. And I'm going to say that that's the width. This width can change, it can move in or out, and we want to find the W such that it maximizes the area. Now, the x coordinate is therefore going to be 8 plus W, because there's 8 units from here to here, because it's the center of the circle, and there's W units from there to there. Right? So x equals 8 plus W. Okay, now that we've got that, I can now put that in there, and I can find W, and then I can find Y. So let's do this. Now, x plus W minus 8 plus y squared equals 64. Yeah, I thought I had a terrible thought. I haven't put that equal to r. It's equal to r squared. Yeah. Okay. Now 8 minus 8 is 0. So this is equal now to W squared plus Y squared equals 64. And now we want to find Y in terms of W. So Y squared is going to be equal to 64 minus W squared. So Y is going to be equal to 64 minus W squared. And I'm going to, instead of putting in the radical sign, I'm going to make it all to the power of a half. So it's the same thing. With me so far? Now what we want to do is we want to deal with the area. So the area of this circle, area of this rectangle, I should say, is going to be 2W times whatever the Y value is. Where Y now we have it as a function of W. That's great because now W contains all the information that we need to find X and Y. And when we do that to find the area, and when we do that to find the distance AD, which is 2W. Should maybe even say it. So the line AD, looks like a P, this AD equals 2W. So the area is 2W times Y, but we know that Y is this. So the area is 2W, 64 minus W squared to the power of half. And now we have a formula for area in terms of one variable. And when we have that, we can now differentiate this. We now have A as a function of W, and we can find A prime of W, set that equal to 0 and maximize it. Fair enough? Fair enough. Let's do it. So I'm going to separate these into two bits. It's going to be U times V. And V itself is going to be, going to need to cut that up into smaller pieces because it's a function within a function. So I'm going to call that U, I'm going to call that V. And I can't call the middle W this time, so I'm just going to do it by the chain or straight as it is. So if U is 2W, U prime must be 2. If V is 64 minus W squared, all to the power of half, V prime is going to be another composite function. So I'm going to call that Z. So Z is 64 minus W squared. So V dash is going to be dV with respect of Z times dZ with respect to W. There's no X in this case used. All right, that's going to be 0.5 Z to the power of negative 0.5. It's just the power rule. Times negative 2 W. Two W is the 2 W. So that's going to be equal to negative 1 W 64 minus W squared all to the power of negative 0.5. Okay, now we have V prime, and now we can find what W is, the maximum, the optimum W by using the product rule. So U V prime plus U prime V. So that's going to be 2W times negative W 64 minus W squared. And I can see a sort of shortcut we could have taken there, but I'm just going to leave it for now. Plus 2 times V, and V is 64 minus W squared 0.5. And that's going to be equal to 0 when we optimize it. But let's kind of simplify this a little bit straight away. This is going to be equal to negative 2W squared. Multiply this out. 64 minus W squared negative 0.5 plus we can't make that any, we can't break that up because we can't sort of multiply that because there's like a things we can't do that. So sort of tempting to go 2 times 64 is 128, but we can't do it just yet. That equals 0. Now we have a negative here and a positive here, so I'm gonna add this to both sides. I'm going to add that to both sides to the equal sign. So we're left with 2 64 minus w squared to the power of half equals 2 w squared 64 minus w squared to the power of negative 0.5. So now you might be looking and thinking, oh, what do I do now? But here's what I'm going to do. I'm going to multiply both sides by this bracket and exponent. Why do I do that? Well, these are almost the same. The only difference is the exponent. And when we add them together, we're going to get to the power of 0. So this is going to cancel. It's going to cancel. So 2w squared. It's not going to cancel that side. It's going to add on that side to the power of 1, isn't it? Yes, it's going to be to the power of 1. So it's going to be 2 64 minus w squared to the power of 1. Yes, so 0.5 plus 0.5 is going to be 1. But you always do that little trick. We can get this gone now. And now it's starting to look really, really good. Now it's starting to look really, really good. So let's divide both sides by 2. So those two are going to cancel. So 64 minus w squared is going to be equal to w squared. That bit. I'm going to just swap sides. And I'm going to add w squared to both sides. Divide both sides by 2. So w squared, they're going to cancel. W squared is 32. And that means that w must be equal to the square root of 32, where it's maximized because we set it equal to 0 and then solved it for w, and that must be, and it says presume that this is the maximum. And we want AD, which is 2W. So, therefore, if AD equals 2W, then AD must be equal to 2 square root of 32. And that's going to simplify to 8 square root 2, and done. So, a lot of tricky tricks there. Um, you could do it a couple of different ways. And there is an alternative answer, I think. You sort of presume that this rectangle is inscribed here, you would get a different answer, I think. But that's the answer that I kind of got last night just scribbling through it. I think I remembered it correctly. But anyway, that's the end of the exam. It was a funny old exam. There were some really, really easy questions and some not so easy, quite tricky ones. I've noticed that there's no implicit differentiation, and there isn't really a lot of sort of advanced calculus differentiation techniques. that used to be in the syllabus that are now not in the syllabus. Be warned that if you go to university or polytech, you to do engineering or science or something like that, you will need to know those. But they're not really much of a step up. But otherwise, yeah, pretty good exam, pretty fair exam, I'd say.